Hello student, I am Nirmala Morade. I am working as an assistant professor in S.V.K.T college, Devali camp. In today's lecture, we are going to study rotation of axis keeping origin fixed, related formulas and some examples. So now, in last lecture we have studied what is meant by translation and the related examples. So now first we see here what is meant by rotation of axis. So now consider our old system. Old axis system, x-axis, y-axis. We rotate this system through an angle, say alpha, where alpha lies between 0 and pi by 2. So the resulting system is x dash, y dash. When we rotate the original axis through an angle theta, we fix the origin. We fix the origin. So we rotate this system. This is xy system. We rotate this system through an angle, say alpha. So this is the angle alpha. Now here 0 is less than alpha is less than pi by 2. So let us consider point P whose coordinates are xy with respect to old system. These are the coordinates with respect to old system or with respect to the original axis of system. And let x dash y dash are the coordinates of the point P with respect to the new system. That is in rotated system x dash y dash. So suppose this is the position of the point P. Draw the segment OP. So let this distance equals to r units. So let distance OP equals to r unit. And one more thing, now consider this angle is equals to say theta. This is equals to theta, that is let angle x dash O P is equals to theta. Now, we write the polar, first we write the polar coordinate of the same point with respect to old as well as the new system. So we know that the first polar coordinate is nothing but the distance of that point from the origin, and second polar coordinate is the angle made by the ray OP with the positive direction of x-axis. So with respect to our old system, polar coordinates of the point P we write the polar coordinates of the point P with respect to the old system. So now first polar coordinate is distance OP. So that is equals to r, and second polar coordinate is nothing but the angle between OP with the positive direction of x-axis, that is we consider this whole angle. And you can observe from diagram it is alpha plus theta. Then we write or express xy in terms of polar coordinates. So we know the relation between these four numbers xy, r, theta plus alpha. So these relations are x equals to r cos of alpha plus theta and y is equals to r sin alpha plus theta. So I denote this as an equation, these two equations as a 1. Then write the polar coordinates of the same point with respect to new system. So first polar coordinate is again the distance of that point from the origin, so which is r, and next angle between OP with the positive direction of new axis, that is x dash axis, that is the angle x dash OP which is equals to theta. So again we express x dash y dash, these are the coordinates of the same point P with respect to new system. So we write x dash y dash in terms of r theta. So now here x dash equals to r cos theta and y dash is equals to r sin theta. So let us this as a equation second. So now here we will try to express, or we will express xy in terms of x dash y dash and vice versa. So now for that consider x is equals to r cos alpha plus theta. So starting from equation 1, x is equals to r times cos of alpha plus theta, which is same as r is equals to, use the formula cos of alpha plus theta. This can be written as cos alpha into cos theta minus sin alpha into sin theta. This is the formula for cos of alpha plus beta. Now just open the bracket here. So this can be written as x is equals to r. I just shift this term here first. R cos theta into cos alpha minus r sin theta into sin alpha. Now use the equation second. In equation second, r cos theta is equals to x dash and r sin theta is y dash. So put this value in x. So x becomes x. Replace this by x dash. Keep this cos alpha as it is minus r sin theta is nothing but y dash sin alpha as it is. So now we express here x in terms of x dash y dash. Now similarly consider the equation second. So from equation second, y is equals to r sin alpha plus theta. So use the formula for sin a plus b. So it can be written as, keep y as it is, r times sin of alpha into cos of theta plus sin theta cos alpha. Open the bracket. So this is same as r times cos theta into sin alpha plus r sin theta cos alpha. Again use second equation. So replace r cos theta by x dash and r sin theta by y dash. So this y becomes y is equals to x dash sin alpha plus y dash cos alpha. So we obtained here the second equation which express xy in terms of x dash y dash. So observe both the equation. X is equals to x dash cos alpha minus y dash sin alpha and y equals to x dash sin alpha plus y dash cos alpha. Here we have expressed xy in terms of x dash y dash when the system or axis are rotated through an angle alpha. Similarly, if you solve these two equations for x dash and y dash, so we will get the equation of x dash y dash in terms of x and y, and that equations are, so I again write these two equations here. So first we write this equation, x equals to x dash cos alpha minus y dash sin alpha and y is equals to x dash sin alpha plus y dash cos alpha. So express here, solving these two equations for x dash y dash, we will get the another equations. X dash equals to x cos alpha plus y sin alpha and y dash equals to minus x sin alpha plus y cos alpha. So these are known as a rotation formulas. So these are the rotation formulas or the formulas. So now let us consider some problems related to it. The first example is find the coordinates of the point P, say 6 minus 3 in the rotated x dash y dash system. If the angle of rotation is alpha equals to pi by 3, that is a 60 degree. So read the problem carefully. We have to given the coordinates of the point P with respect to old system, that is here x is 6 and y is minus 3, and now we have to calculate the coordinate of the same point with respect to the new rotated system if the system is rotated through an angle pi by 3. So for that you can use these formulas. Since we required x dash y dash, so express x dash y dash in terms of xy. So for that first we have to calculate cos alpha and sin alpha. Alpha is given here, which is pi by 3, that is a 60 degree. Then calculate cos alpha, that is pi by 3, cos of pi by 3, and cos of pi by 3 is half. Similarly, calculate sin alpha, that is sin pi by 3, which is root 3 by 2. Sin alpha is root 3 by 2. So at least you have to remember the sin and cos for the standard angle like 30 degree, 45 degree and 60 degree. So now next write the formulas. X dash is equals to x cos alpha plus y sin alpha, and y dash is equals to minus x cos alpha, x sin alpha plus y cos alpha. Now put the value of xy as well as sin alpha, cos alpha. Therefore x dash becomes, x dash is equals to x is 6 into value of cos alpha, which is half, plus y is minus 3 into the value of sin alpha, which is root 3 by 2. Similarly, in y dash put the value of x as well as sin alpha, cos alpha. So x is 6 here, so minus 6 times sin alpha is root 3 by 2 plus y minus 3 times cos alpha is half. Now just solve it. So x dash is equals to 3 minus 3 root 3 times by 2, and y dash is equals to minus 3 root 3 times minus 3 by 2. So these are the coordinates of the point P in the rotated system. So remember, if you know x dash, y dash and the angle alpha, you can calculate x dash, x and y by using these two formulae. And similarly, if I know x and y as well as the angle alpha, then you can calculate x dash, y dash by using these two formulas. So let us see how to convert the given conic in terms of the given conic in standard form in the presence of xy term. This is our second example. Prove that the conic is a ellipse, is a hyperbola by rotating the axis through an angle pi/4. So read the example carefully. Prove that 2xy minus 9 equals to 0 is the equation of hyperbola by rotating the axis through an angle alpha equals to pi/4. So now first we have to rotate the axis through an angle alpha, which is pi/4. So first we have to write the rotation formulas. So we use these two formulas, express xy in terms of x dash y dash. So the given thing is alpha equals to pi/4. So first we have to calculate cos pi/4 as well as sin pi/4. And since we know that cos pi/4 and the value of sin pi/4 is same, which is 1/√2. Then write the rotation formulas. So rotation formulas are x equals to x dash cos alpha minus y dash sin alpha, and y is equals to x dash sin alpha plus y dash cos alpha. Now here put the value of x cos alpha and sin alpha only. So x becomes, x is equals to, keep this x dash as it is. Value of cos alpha and sin alpha both are same, which is 1/√2. So directly when we put here cos alpha equals to 1/√2, sin alpha equals to 1/√2, and take 1/√2 as a common. So it can be written as x equals to x dash minus y dash upon √2, and similarly y can be written as, by putting the value of cos alpha and sin alpha as a 1/√2, so it will becomes x dash plus y dash upon √2. Now since we find the transform equation, that is equation of this conic in new system, so substitute these two value in the equation of the conic. The equation of conic is given as 2xy minus 9 equals to 0. Therefore keep 2 as it is. Value of x is x dash minus y dash upon √2. Value of y dash is x dash plus y dash upon √2 minus 9 equals to 0. So this can be written as 2 as it is. One bracket contains x dash minus y dash, that is subtraction, and one contains addition of these two numbers. So by using the formula a minus b, a plus b, it will be a square minus b square. So this is same as x dash square minus y dash square upon product of these two term is 2. Shift this term to the another side, that is 9. Then this 2 gets cancelled here. So it becomes x dash square minus y dash square is equals to 9. Now divide throughout by 9. So we get here x dash square upon 9 minus y dash square upon 9 is equals to 1. So if we compare this equation with the standard form of the conic, so it represents the hyperbola. So this equation is hyperbola. This is the equation of hyperbola. So now when xy term is present there, we can reduce that in that conic in the standard form by rotating the system. So in today's lecture, we have learned what is meant by rotation. So we rotate the system through an given angle alpha, keeping origin fixed. The rotation formulas are x equals to x dash cos alpha minus y dash sin alpha, and y is equals to x dash sin alpha plus y dash cos alpha. Similarly, solving these two equations for x dash y dash, we will express x dash y dash in terms of x dash x and y also. Also, we reduce the conic in standard form by rotating through an angle alpha. Next lecture we will study how to transform, or what is the relation between the coefficient of the conic ax square plus bxy plus cy square plus dx plus ey plus f equals to 0 in new coordinate system. Thank you.